Hello boys and girls, this is Mr. Giomini. Going to explain / model 3 questions from your Unit 5 pretest. I think once I've modeled these 3 you'll have about 5 or 6 of the 8 to 10 questions on it, 9 questions maybe. So you'll have a good sample size of the pretest answer for you as well as the answer key that's on the blog. But I did want to give you a little bit of a better explanation in case looking at the questions on the blog you're not quite sure of why I chose an answer. So let's take a look here. I'm going to read the directions first. It says triangle KLM is a scalene acute triangle. Circle the right triangle, or sorry, circle the triangle similar to triangle KLM. So circle. Let's make my little highlight a little bigger. Circle the triangle that is similar to triangle KLM. Now, I think on the pretest someone was a little confused of which triangle was KLM. Well, all you really had to do is look at the letters that go around it, and that'd be a good indicator of which one KLM is, and this is the only one that has a K in it, KLM. Now, keyword here is similar. So we have to find a triangle that's alike this one. Now, just visually looking at them, they all look alike. They all look to be acute scalene triangles. Scalene meaning none of the sides are congruent, acute meaning all the angles are less than 90 degrees, but greater than 0. So I'm just going to now focus not necessarily on the actual physical look, but now I'm going to look at the focus on the numbers and the lengths of the line segments that make up the individual triangle. So I see this side is 4, this side is 2, this side is 5. I'm going to look at each triangle individually. So this side is 2, this side is 5, and this side is 6. So if I'm comparing triangle WXY to KLM, I see that these two line segments are congruent, but everyone else is different. So there really isn't similarities. You know, if for similarities, because every side, all 3 sides have to have something in common with the other one. This one, there's nothing in common with the exception of this line segment's congruent. So I can eliminate this one. Let's go to the next one. I'm going to go to triangle WXY. Notice they're all WXY. Looking at WXY, I see that 4, 5, 5, 6, 2, 3. Now, we might say, hey, wait a minute. They're all 1 inch or 1 centimeter, sorry, larger than the other. But we talked about scale relationships or proportional relationships like a 1 to 2 relationship or a 1 to 3 relationship. Well, we can't have a +1 relationship. So that's why this would be eliminated. I come here, I see that this is 2, this is 4. Well, this side is 2 times bigger than this side. That makes sense because that's a 1 to 2. Side KL is 4, side WX is 8. Hey, that's 2 times larger, so times by 2, times by 2. That's looking good. Now 5 and 8. Well, 5 times 2 is not 8, so there goes my proportional reasoning out of the window for that answer. I go to the final one here. Okay, line segment KM, line segment WY, they correspond with each other. Well, this is 2, this is 4, that is it doubled, so that would make sense. Excuse me, line segment WX and line segment KL, this is 4, this is 8. Hey, that's 2 times larger, that makes sense. Now let's go to line segment ML and find the corresponding side, which is line segment WX, or YX, I'm sorry. Good job knowing my alphabet. 5 is, hey, you know what? 10 is 2 times larger than 5. Notice this. This is the 1 to 2 relationship that we've talked about a little bit in class. This is my 1. This is 2 times larger. So the correct answer, this is the triangle that's circular, or similar, sorry, to triangle KLM. Take a look at another one. Miss Banjoff's garden is 5 feet by 6 feet. Explain how the perimeter and area change if the length and width are doubled. Use calculations and pictures to represent your solution. Miss Banjoff's garden is 5 feet by 6 feet. Explain how the perimeter and area change if the length and width are doubled. We're going to double it. Use calculations and pictures to represent, that's a fancy word for show, your solution. So, let me draw Miss Banjoff's. I'm going to go MB, and I'm going to call this the O, the original garden. Well, the original was 5 by 6, let's say, which it says. So 5 by 6. 5 by 6. Now let's calculate the perimeter. and the area. Well, the perimeter for this is just all the sides added together. So 5 plus 6 is 11. That's 5 plus 6 is 11. 11, 11 is 22. So it was 22 feet for the original. Area is length times width. 6 times 5. 6 times 5 is 30. So this is 30 feet. Okay, that's the original one. Now we need to go to her new one. So I'm going to call this new. So Miss Banjoff's new garden, if I go back, it says, how would it change if the length and width are doubled? So I have to double each side. So this side is no longer 5, it is 10. This side is no longer 6, it is now 12. And that corresponds, so if this side's 10, then that means this side's 10, this side's 12, this side's 12. Okay, so the perimeter, the distance all the way around her garden. 12 and 12 is 24, plus 10 is 34, that's 44 feet. So just looking at the relationship between the perimeters, to me it looks like the perimeter doubled. Got 2 times larger. Let's look at the area. Area equals length times, length times width. Length times width. So it's length is 10, or 12 times width is 10. 10 times 12, and I have to write all these in the box here. It's 120, and that's 120 square feet I should do with area. How did I get 30 to become 120? I times it by 4. So if I were to write an answer, now I don't necessarily have to, because it says use calculation pictures to represent your solution. I could also say, if I were to type this out, and let me try to write a small font. How about a different color too? The area would double, and the area, I'm thinking perimeter, the perimeter, always important to check your answers, the perimeter would double and the area would quadruple. Alright, let me just double check, make sure it makes sense. The perimeter would double, so perimeter 22, 44, yes, check. Area would quadruple, 30, okay, good. So that's how I do that one. A lot of kids miss this one, and I think if you drew a picture for yourself, it might have helped you out a little. Last one. Mrs. Plow has 2 rectangular dog pens that have the same area but different perimeters. Each dog pen has an area of 48 square feet. Draw 2 different rectangles with an area of 48 square feet, but with different perimeters. Then determine which will design require fewer materials. So, go back in here. Mrs. Plow has 2 rectangular dog pens that have the same area but different perimeters. Each dog pen has an area of 48 square feet. Draw 2 different rectangles with an area of 48 feet but with different perimeters. Then determine which design will require fewer materials. Okay, so I know that the formula for the area of a rectangle is area equals length times width. Well, I could do a little algebra here and say, hey, I got to have the area being 48. So what 2 numbers can I multiply together to get 48? Well, the easiest 2 that I know of is 6 times 8. So I couldn't have a dog pen that is 6 by 8. So let's see if I can be a little neater. So here, and let's make my rectangular dog pen. So there's one dog pen, and I'll label the dimensions. That is a 6 by 8. The area would equal 48 square feet. We'll call these feet. The perimeter would equal, let's see, 8 and 6 is 14. That side's also 6. This side's also 8. 14 and 14, the perimeter is 28 feet. Now I need another 2 numbers that equal 48. Area equals length times width. What times what equals 48? Well, I could just take half of 48 because it's an even number. 2 times 24. So I'll draw another rectangle. This time with new dimensions. We have a side that's 24. We have a side that's 2. 2 times 24 is 48. That's how we find the area of a rectangle, length times width, so it's 48 square feet. This side would also be 24. This side would be 2. So the perimeter is 24 plus 24 is 48, plus 2 is 50. Plus 2 is 52. The perimeter is 52 feet. Now, determine which design will require fewer materials. Well, I need to build a fence, and the fence needs to go on the outside, obviously, or around the dog pen, not inside it, so I'm figuring out the perimeter. Well, I already know the perimeters. This perimeter is 52 feet. This perimeter is 28 feet. So, I could tell you right now that this one will require fewer materials. So, I will type out an answer. The dog fence, or the dog pen I'll use. The dog pen with a length of 6 feet and a width of 8 feet would require fewer feet of fencing than the other design. And I am done. Alright, those are 3 questions. I hope you use them to help prepare for the post test, which will be next week. Take care. Bye.